Hello, this is Physics with Harrison, and today I'll be talking about problem 11-3 from our physics work blue packet. So 11-3 starts with a conducting rod that is free to move on a pair of horizontal friction conducting rails distance L apart. And the rod has a resistance of R, or the rails have resistance of R. And we have a magnetic field into the page with force or magnetic field of magnitude B. So the rod and the rails don't have resistance to each other, and at t equals 0, this has a speed of v to the right. So part A, we're asked to find the induced voltage. So E is induced voltage, the theta of that over d that, as we're given in the table of equations. From this you could derive that the flux equals to the integral of B. Well, we know that the flux equals to the integral of d dA. So we sub that in. E equals negative B dA over dt. So we have the t and change of t doesn't really, well, change of t and over change of a over change of t would equal LV. So E equals negative B LV naught. As seen from our table equations. Doesn't it seem familiar? Now, part B is a little bit trickier in my opinion. So part B asks for the magnitude and direction of the magnetic force on the rod at t equals 0. Start by saying that F equals ILB, because B is perpendicular, so you multiply it. So, well, it would be IL cross B, but it's just, doesn't matter. It's just F equals BIL, BIL, or ILB, however you want to say it. And we also know that I equals E over R from our table equations. Well, it has the absolute value because current can't go backwards. And we need a positive value for this. So we substitute the E in, and everything in, so F equals E over R LB, which equals B LV naught over R LB. So yeah, F equals V naught L squared B squared over R. That's fine. So we have to include the force on the, so we also have to say that the force is opposite direction of velocity, because that's what it asked for in the problem. So we know that the direction would be negative. So this number actually equals negative v naught L squared v squared all over r. Good? Okay. So it shows that the force is in the opposite direction of the velocity. Alright. Now for part C. Part C, they tell us that they want us to find the speed v of the rod as a function time t. So we could start by this by saying that F equals ma. Newton strikes back. So we have F, this is VB squared L squared over R times M, equals M A. So A equals VB squared L squared over MR. So this is also negative from our previous answer, and because we need to show that acceleration is opposite to the direction of velocity. dv, now we have to solve for the correct differential equation, which equals negative v squared L squared for MR. So then dv over v equals negative v squared L squared MR dt. Separation. So then we integrate both sides and we get this. We get that ln of v over v naught equals negative bl squared, or b squared L squared over mrt. So v equals naught e to negative b squared L squared t divided by mr, because we have to solve for v. There is your answer. But that's not all, folks. We still have a part D. Ha ha ha. So part D just asks us the total energy dissipated in a resistor began in time equals 0. We could use this little space right here because the problem shouldn't be that tedious from the looks. So, well, because it slows down, so energy conservation laws, we have the beginning velocity, k, so energy equals k for 1/2 mv squared. Conservation of energy, that should be our answer, because eventually it will stop and all the energy will be used up. Part D. And looks like we use last. So that's really it. So thanks for paying attention to this video, and peace.